Hello, everybody. Welcome to the job submission manual module. So now that we have talked about how does Slurm work, how do you log in, how does the HPC run, we're going to talk about a bit, first of all, different types of jobs, and then how you can submit your own jobs. Okay? Now let's go. First of all, there's two types of jobs. There are non-interactive jobs. Those are the most common ones, right? So here you submit everything. You submit your data, your parameters, and your executable files through the command line, right? And then you get an output, right? Then the interactive jobs are usually submitted through Open On Demand. So those are the ones we talked about, like R, Jupyter Notebooks, etc. You can do them through the command line. We'll actually talk about it a bit today, but we're going to focus on non-interactive, which are the brunt of the jobs that you will submit when using our high-performance computing resources, okay? Let's get right into it. First of all, what are the elements of a job? A job runs a program with added data, optional data that you're going to run through the program to then get an output, right? And then you need something in addition to that program that specifies resources that it will use. So this says how much time is it going to spend on the HPC, how many cores is it going to use, is it going to use GPUs, graphical processing units or not, what Slurm partition is it going to go through, etc., etc. And we do this by using a submit script. So we'll talk about how to make a submit script here. And then the command and the OD open on demand parameters. Okay. So here we see an example command running a job. So srun submits the job. And then that dash A tells it which partition, the backfill partition, how much time, number of cores, etc. Okay. This is how it looks on a single line. But submit scripts let us organize this on a file and submit that file instead, right? Which is really nicely. And we'll see it right after this one, right? So the submit script looks like this, okay? Now, that submit script has a couple of jobs together. It tells the job scheduler what to do, how to execute it. It has flags. You see a hashtag at the beginning. You see it in the next slide with the dash and something, and that will tell it what it's talking about. And then it's run with an srun in the script. So that's how you start parallel tasks on a submit script. Okay. Now, most of the time, a script we're talking about a bash script. You can use any language with hashtag style comments. Will work Python or Perl. But most of the time, we'll talk about bash here. Okay, so this is how it looks. It's an example job script. Now if you want to run your own, I suggested go through our docs and you'll be able to find the SPC's job reference there. Okay, let's talk about the composition, the essentials per se. You need first to have a job name. So that's dash J, the name of that job. In this case, we're calling a test. Dash A tells us which Slurm account. So basically which line you're going to throw the job through. Okay. That's a dash A and the name of that queue. In this case, general access queue. Okay. Dash N tells us how many cores. In this case, we're saying 4 cores. Okay. Dash T tells us the time. In this case, 15 minutes. And then mail type tells you, do I want an enable notification? If you put all, you're going to get an enable notification when you're done. Now, the rest of the commands are actually the commands that you would write when running this job by manually on the command line. So in this case, we're going to load 2 modules, Intel MBA Pitch 2, and we're going to run the trap. Okay. So that's basically how submit script works out. Okay. Now, let's talk about a bit about Slurm accounts. Remember that Slurm accounts, you have the general access ones, you may have a specific partition. If your professor or your lab professor, like if your lab professor has asked for one, okay. If now you're going to be able to use general access queue, backfill 2, Condor, and quick test. All of these have different parameters. Please familiarize yourself with what does each one have in terms of max run times, how many CPU cores per job you can use, how many jobs per user you can submit, right? And these are important. Now, let's talk about what like Slurm does. So we talk about like Slurm, you submit the job and then it uses a first show algorithm to make sure as many people as possible get the resources at one time, right? And that is why we use the job, the submit script. Now, you can also build job scripts, the scripts themselves, using our submit script generator. Okay, so you don't have to write it manually. It's actually linked on our doc. So please go ahead and use it because it will make, especially when you're starting out, it's really easy to get that format wrong. So go ahead and use our submit script generator and then edit it out however you want. Okay, now, how do you select which Slurm account to use? Okay, As you remember, is that dash A line with the S batch. So if you want to do a quick sub 10-minute test, you want to make sure this runs, but you're not running any big data through it, use quick test, a sub 10-minute test. If it's going to take less than 4 hours to run, use Backfill or Backfill 2, right? If it requires for you to use MPI or OpenMP, consider using Condor or General Access Queue. And if your lab or professor has purchased HPC resources, use your dedicated accounts, okay? Now, we're not going to go in depth into what MPI or OpenMP requires, but we do have a lot of documentation on these, so go ahead and read it. And you know if you have to use it, you'll see it there. If not, ask us, okay? Now, last thing, I know there's a lot in the submit scripts. Last thing is memory. So you can specify memory or memory per CPU in terms of megabytes, and the default is 2 gigabytes per core, 4 gigabytes on Backfill 2. Okay, now under the hood, memory are mapped to specific cores. So in this case, you can see dash N1 memory 5 gigs. It will reserve 2 cores on a node, and the wait time will increase if you ask for a lot of memory. Okay, so please keep that in mind. Okay, that if you ask for more memory, it will give it to you, but it will take longer to allocate that just because it has to separate it. Okay, now now that we went through everything, how to select the server account, how to put memory if you need it, how to write it out, and if you want to use a submit script generator, you put everything together, and now we actually have to submit. So what are the steps? Step 1. We connect VPN or FH Secure. Step 2, we SSH to the HPC login. Step 3, we create the SBatch, the submit script, my bad, and we submit that using SBatch to submit it, the command, SQ to check it, to check if the job went through. Okay, so let's see how this looks all together now. Okay, so this is an example that we ran. We're gonna SSH first, right? We assume we're already on the VPN or on FSU Secure. Here we go. The site, I'm gonna wait there. You're in, we're going to CD into wherever that submit script is. Okay, in this case, it's going to be in seminar slash parallel. Find it there. We do SBatch, submit the submit script trap.sh. It's submitted. We use SQ to check. Okay, everything makes sense? Let's move to the next. These are the commands that we did in that example. You can also instead use RCC tool my::jobs to check the jobs that you're running at the moment. And if you haven't heard about RCC tool, I recommend you look at our documentation. We have a list of commands that have been developed in-house to check your jobs, to check memory usage, to check your data storage, and they come in real useful if you're doing a lot of work on the HPC. Okay, so we have it there for you and for us. We use it all the time at work. So I really suggest that you take a look at it. Okay, if not, this is the main anatomy of how to submit jobs. SSH, SBatch your job, or touch if you want to create that file, and then SQ-SB. Okay. Now, let's talk about a bit of a submit script generator. As I said, when you're starting out, this is where you're going to be doing the brunt of your work. In interactively generates a Slurm script. It has some checking, but I would just take that with a caveat, and it has templates for some of our software. Okay, so this is how it looks, right? You write a job name, you put the executable file. Now remember, you already have the executable file, so you got to put that exact name in or it won't run correctly. Select which partition, the number of cores, the runtime, right? And then that creates on the right hand side that script. You can copy, paste it, done. Okay. So when starting out, this is a great tool to have. Yeah. Now, we talked about how to submit a very basic one, but what happens if we want to, like I said earlier, load modules? In that case, before we loaded the module Intel and MBA Pitch 2, right? So if I want to add more, you have a couple options for adding software or modules. You can run one of the many software packages we already have installed. Please check our software list. Number 2, you can ask us to install one. We generally do if we have time, like we adjust our time to work around it. 3, download the source code, compile it yourself. I would not recommend this one if you have not done it before, and compile and run your code. If you want to learn to do your own compilation because you think you'll be running a lot of different softwares, please go ahead and learn. But we do not require that, and we're very much happy to receive your requests for installations. Okay, and those are some of the examples of the stuff that we already have in there. Okay, now after everything's said and done, you submitted everything. What happens at the end, right? After submitting the SBatch, you saw that you got submitted batch job, and it gives you a job ID. Now you can find the output file for that slurm-job ID using that same my job ID. to find that output file. This will tell you if there were any errors with the run, and usually results come out so you print it to the screen if there was anything to print out from your results. Now, if you ever find errors, they will be in that output file. So that is, finding that output file will be a great skill if you ever need to ask help from us or from one of your colleagues, right? Being able to send that error file around, that output file around. Okay, and I hope that was useful, and I'll see you for the next video.